Hello guys and welcome back to another video of Architects 3DP. This is the 16th episode of the Build the Best DIY 3D printer series. In the last episode, we finished the installation of the very last hardware component of the 3D printer, the motherboard, as well as we made the cable management. This last component is composed basically by the Arduino Mega 2560R3, the RAM's 1.4, and the stepper motor drivers. In this video we're going to start programming the firmware of the electronics built last Friday. Now I'm gonna teach you how to correctly configure the firmware for your 3D printer. But before starting, be sure to subscribe and to ring that bell to be notified when cool stuff is uploaded. If you do it, you will help me creating new content and growing the channel to reach more special viewers like you. In these two videos, we're going to be alternating in between 9 sections of the configuration that will be appearing along the video in a kind of random order. Anyways, all the features we will work with will be part of these sections. Section 1 – Info. Section 2 – Machine. Section 3 – Extruder. Section 4 – Temperature. Section 5 – Homing. Section 6 – Motion. Section 7 – Probes. Section 8 – Calibrate. And Section 9 – LCD. Okay, so the first part that we'll need to start with the build of this video. No, I'm kidding. In this video we're gonna be using our computer. I'm gonna do it using Windows operating system, because I think it will be the OS that most of you use. Anyways, the process in macOS is very similar, and I don't think you will have any problem. Alright, so the first step will be to open your web browser, and we'll navigate to arduino.cc. This is the software we are going to use to program the Marlin, so we'll click in the Software tab. Here you have to click on the Windows installer if you are using Windows or Mac OS X if you are using Mac. And then a new screen will appear. Arduino is a free open source software, but you can make any donation if you want to contribute with them. I would recommend you to donate something because all of us want the platform to keep improving, and donating at least €3 is a small step to make it better. Alright, so once you choose if you want to donate or not, you will have to click here in Contribute and Donate, or here in Just Download, and the zip file will be downloaded. Then we'll uncompress it and install the app. Perfect! Now we have the Arduino app up and running. Now we'll navigate to marlinfw.org and we are going to click here in Download, and then in the latest release. In our case it's the 1.1.9, but you have to download the last one in case any other version has been released. Once downloaded, we'll unzip it and we'll change the name 1.1.x for 1.1.9, so we'll easily recognize the version in the future. Now we'll open the folder. Open the folder named Marlin as well, and inside this folder we'll search for the file Marlin that we are going to open with the app we just installed, Arduino. Alright, so here we have the files conforming the firmware we'll be flashing into our Arduino Mega 2560R3 we installed in the previous episode. This file has a lot of tabs, but we are basically going to work in the 5th one, named configuration.h, and maybe we'll also touch something from the configuration advanced, for some possible advanced settings. Okay, so we're going to click on the configuration.h file and go step by step analyzing the different options that the file includes. Here on top we have the version, copyright, etc., nothing that concerns us. And here we can see a small index of what we're going to find in this file. As you can see, we will have to define the type of electronics, type of temperature sensors we are using, the printer geometry, the configuration of the end stops, the LCD, and other features that we will set up. Finally, as I said before, advanced settings can be found in the tab configuration advanced.h. Next, in getting started, we can find several links that we will possibly use later. And next we have some specific configuration for special types of 3D printers. Since we are going to be using a Cartesian system in the Prusa i3, we can delete these paragraphs, or well, leave them commented like they are. Notice that in every line you have this double slash, the line will be just commented, so it will not actuate as a command. Alright, so you can leave them as they are by default, but if you want you can do like me and delete the 3 paragraphs, Delta, Scera, and Hank Printer. One more time, deleting them is just for personal comfort, and it does not matter if you do it or not. Alright, so continuing we have the section 1, Info. Here you can change stuff like the author, the boot screen, etc. I'm going to make a really cool change, that is to implement our Architects 3DP logo in the boot screen. but I will make it in a dedicated video since it's so cool. So for now we're not going to make any changes in this code. Next we'll enter the section 2, machine. Okay, so we're going to leave the serial port like that. For the baud rate, we're gonna stay with the 250,000, and if later we have any kind of issue with the communication with our PC, we'll reduce it to 115,200 bauds. Next we have the Bluetooth configuration, that we are just going to delete since we'll never use it. And right after we have a very important part of the file. We have to define here the motherboard we are using in the build. By default, the board defined is the RAMPS 1.4 EFB. This means extruder, fan and bed, and are the devices that we connected last week right here, extruder, fan and bed. We have the exact same configuration that is written by default, but anyways, if you go to the tab boards.h, here we have all the codes. For the RAMPS 1.4, we can use, for example, extruder fan bed, extruder fan fan, extruder extruder fan, extruder bed, etc. Same stuff if we are using a different board, like for example our 2CTC Prusa i3 Pro B is using the board GT2560 Ref A, so we will have to use this code right here. Okay, so after this small parenthesis we are going to delete the next 2 paragraphs and continue with the code. As you can see, it's going to be quite a long video, but I prefer to make an in-depth description of all the file, so you will become a real expert in Marlin along with me, because of course I'm not. Now we're going to enter in the section 3, extruder. So easy, the first parameters will define the number of extruders. As we only have one, we'll define extruders 1. Next, the filament diameter. By default, in this case, the filament diameter is 3 mm. We'll change it since the filament we're going to use is going to be 1.75 mm. So we'll write it down. We're going to delete the next paragraph that is meant for multi-extruder printers, and also the next paragraphs that are made for the Prusa i3 MK2 multi-material extruder. Since we are not going to use it, we're going to delete the explanation, the define, and the conditional. We'll do the same for the next 2 cases, meant for dual extruders. That is not our case. The next paragraphs are for double extruders as well, so we can delete them too. So as a summary, we have to delete everything since the line after filament diameter till the next time we see the title at section machine. So once again, inside the section 2 machine, we can see that the first defines the type of power supply. By default is set to 0, and we're going to leave it like that. The next conditional will always be false since it's set to 0. Next, we're going to enter into the section 4, temperature. In the thermal settings, we're going to set the thermal sensor models that we are using for the thermal sensor in the extruder as well as in the heated bed. So we have to check the list and identify the one we are using, or the one that is more similar to it. If you buy the one I specified in the last episode, as well as in the bill of materials, the nearest to the exact same model will be the number 13, the 100K Hisense 3950. So we're gonna scroll down a little bit and we're going to define the temp sensor 0 to the code 13 like this. For the sensor of the bed, we'll use the same sensor, so we'll use the code 13 as well. And finally, there is the option to set the sensor of the chamber in case you are using an enclosure. But we're not using it for now, so we'll leave the value 0. Next, we'll not change the dummy thermistor options. And next, there is a possibility to use redundant temp sensor for safety. We're not going to use it, despite it's a very cool option safety-wise. The next options are related with the timings and temps of the extruder till the command M109 of the G-code returns success and the print can start. The values by default are okay and will not change them. So basically, if for example we set the target temperature to 200 degrees Celsius, it will be considered close to the target temps in between 197 and 203 degrees Celsius, and the 10 seconds timer will begin once the temperature is in between 199 and 201 Celsius. The next paragraph defines exactly the same for the heated bed, so we'll leave it like that as well. Next we have a safety feature again. This command defines the minimum temperature below which the heater will not be enabled. It's used to check that the wiring to the thermistor is not broken, what could cause a fire in our 3D printer, since the extruder will be powered on all the time. This way, if the cable or the sensor are broken or just unplugged, the printer will stop working for safety. Same happens basically with the next settings. In this case, for the max temperature, it's set to 275 degrees Celsius and it's okay. Temperatures over that value could melt the components of the extruder if we're not using an all-metal extruder. Even though I'm going to set the temperatures down a little bit, since we're not going to print any filament over 250 degrees Celsius. We're going to set it to 250 for all the heaters, and we're going to set the max temp of the bed to 80 degrees. Next we'll find the PID settings. It's activated by default, and we're not going to change any setting here. Down below we have the PID settings for the bed. We're going to activate it as well, so we'll uncomment this command define PID temp bed. And right below, we have a portion one more time of the section 3 extruder. These values are set to prevent temperatures below certain degrees, as well as max length for a single extrude. For the extruder min temp, I'm gonna set the temp to 165 degrees Celsius, since we could break the extruder if we try to extrude material under this temperature. And we're going to leave the max length to 200. Next, we'll find the thermal runaway protection. It's another safety feature from Marlin, and we're going to leave it activated as it is by default. The next section is to activate the core XY, kinematics, and so on. Since we're not going to use it, we're gonna delete the complete block. Next we have a very important block that are the end-stop settings, and we're going to start with the section 6, homing. First you have to define the connectors that we're going to use. As you may know, we have installed two end-stop, one for the x-axis and one for the y-axis. Also, we have installed the pinda sensor in the extruder to set the z-axis 0. So we will define x-min, y-min and z-min plugs only. Then we're gonna let activated the end-stop pull-ups for now, and in the next block we can choose if you want to invert the end-stops or not. For the specific cable configuration I've used, I'm going to set the x-min, y-min and z-min to true, and I'm also going to set the z-min probe end-stop inverting to true. In the next block, we can set the end-stop with the stepper drivers. We're not going to use this feature for now, so I'm going to delete the whole block, as well as the noise filter settings. Then we have another block, movement settings, and it starts with the section 6, motion. Alright, so here in the default axis steps per unit, we have to set the steps per unit for the X, Y, Z, and the extruder. Depending on the stepper motors, the belts, the extruder, and the Z-lead screw you are using, you have to set different steps per millimeter. If you go here on top of the Getting Started section, you have a set of links that will help you setting these parameters. For this case, if you go to the calculator, in the stepper motor section you can select the type of step angle, the belt pitch, the pulley tooth count, etc. Here you can calculate the number you have to set in the Marlin. So back in the Marlin, if you use the same components I explained in the videos of the build, you have to set these parameters. 100 steps per millimeter for the X and Y axis, 400 for the Z axis, and 160 for the extruder. So yeah, if you use the same components I said, just copy these values and they will work just fine. Same happens with the max feed rate. From the side of security we are going to lower these values to 200, 200, 3 and 25. For the acceleration we are going to keep the default values as well as for the jerk. Finally we have the S-curve acceleration that we are not going to activate for now, and maybe we'll do it in a future video. Right next to it we'll jump into the next block, set probe options. Entering the section 7, probes. Here we are going to set the pinda sensor that we will use for the Z-axis auto-home, bed leveling, etc. First, we can see that the Z-min probe uses the Z-min end-stop that we activated before. So here is the command to define this case. Next, we have the option to change the pin used, but since we have used the one set before, we can delete this whole block. Next, we are going to skip this manual probe block and we'll go with the fixed mounted probe section. We'll uncomment the define fixed mounted probe to activate it like this. And down below, we'll find a set of settings that we can change to improve the accuracy of the probing. It's more useful for the bit touch probe, so for now we're not going to use this improvement. Only if we see unreliable readings out of the sensor later on. Next to these parameters, we'll find a section to define the different offsets in between the nozzle and the probe. Here on the bottom we can see a graphical scheme. From here what we can extract is that from left to right is the positive x-axis and from the front to the back is the positive y-axis. Once we know that, we're going to measure here in the 3D printer the x distance in between the nozzle and the probe that, as you can see, is 22 mm. Okay, so back in the Marlin, we're going to set 22 in the first value right here. Back in the 3D printer, we're measuring now the distance in the y-axis, and the gain positive, it's 10 mm to the back, so we'll set this value to 10. Finally, the Z offset, that if we measure in the 3D printer, we can see that it's more or less 0.2 mm above, so we'll set the value to 0.2. We're going to leave the next adjustments as they are by default, till we reach this text block in gray. Here we'll set the Z-axis clearance in between the different probes for the bed leveling. So for the first one, we're going to lower it a little bit, setting it to 7 mm. For the clearance between probes, we're going to leave it at 5, as well as the multi-probe clearance. Finally, we'll uncomment the Z after probing command, setting it to 5. We'll next keep the default settings, also here in the section Extruder, and we're going to stop in the next section to Machine. So here what we're going to do is to change the direction of the Y stepper motor, since I think the cable configuration I've done will need to flip this particular axis. Anyways, you'll be able to change it later, so don't worry. Next we'll enter again the section to Machine, one more time. Here, depending on the extruder you are using, you have to set it to true for a V9, or as is in our case, when we're using a geared extruder, we're going to set everything to false. Now we're going to enter the section 5, Homing. We're not going to change the first 3 parameters, and next we have to check the homing direction. Since we used the min x, min y and min z pins, we'll be homing to the negative direction, so we'll set -1 in all the values. Next, back into the section 2, Machine, we have to set the size of the print bed. If you bought the same heated bed that I did, the real measure of it is 214 by 214 mm, so we're going to change these values to 214. Next, we're going to set the travel limits after homing. Here, I'm going to explain you how it works using the 3D printer where I have already flashed the Marlin, but it will be useful for you as well. Alright, so first I'm going to make an auto-home. As you can see, the min X and min Y end stops are actually outside the bed of the printer. Now I'm going to move the X-axis manually, millimeter by millimeter, until it reaches the real end of the heated bed with the nozzle. So first I'm gonna lower the Z-axis, and now I'm going to align the X-axis. I'm going to move it to the left, and as you can see, right when we reach the edge of the heated bed, the X distance from the X0 is exactly 20 mm. Alright, so back into the Marlin, we're going to set the X min position that was set to 0 to 20 mm. Now we're going to do the same with the Y-axis. So this time we're going to move the nozzle to the front, and as you can see right in the edge, the printer shows the distance of 3 mm. So that's the value we're going to set here in the Marlin. Next we are going to do the same for the maximum positions. So we're going to bring the X-axis to the right edge, and as you can see it's exactly 233 mm. So back in the Marlin, we'll set the X max position to 133. Same for the Y-axis. In this case, the number that we are looking for is 217 mm, so we'll write in the Y max position 217. Finally, for the Z max position, we're going to move the Z-axis up until it's reaching the end of the lead screws. This way, we're going to read the value here, and the number we'll use for the Z max position will be 202 mm. So back in the Marlin, we'll write 202. Alright, so the travel limits are all set up, and next we'll skip the software end stop block, as well as the filament runout sensor, since we're not using one, and we're done one more time for this section. The next settings are about bed leveling, where we'll start the section 8 calibrate, but we're gonna do it in the next episode. Alright, so finally after this quite dense and long video, we can say that we are done with the first half of the Marlin configuration. Next week, we will finish with the complete configuration of the firmware of our 3D printer. You should advance your Marlin until the point we are right now, and try to read and understand what we have left in the configuration.h file. You can check the components we used in the BOM of bill of materials that I will link down below in the description of every single episode. Alright, so not much more to say, keep playing with the Marlin and we will finish the complete configuration in the next episode. So be sure to subscribe to my channel and to ring that bell to be notified when cool stuff is uploaded. Hit the like button if you like the video, leave a comment and share this episode so more people can learn with this project. Finally, I just wanted to give a special thanks to all of you, and especially to our Patreon supporters, for continuing to make this channel possible. If you want to join them and support the channel as well, getting nice rewards and making me super happy, you can do it navigating to patreon.com/architects3dp or clicking here in the top right corner. Okay guys, so as always, see you in the next video.